Okay then guys, let's have a look at the intro for this section on trig identities. Here's the equations we most often use, so I've put them down here at the top. The trig equations that we need, and the sec and cosec, what values they are, and the cot here as well. So let's have a look at the example and see the sort of things we need to review to go into this section. So here, basically we're proving that the left hand side is identical to the right, so it's a trig identity. And we can do it in one of three ways. We can start from the left and journey all the way to the right, so to speak. We can start from the right and journey back all the way to the left. Or, in some problems, it's preferable to start from the left and get to the middle somewhere, and start from the right and get to the middle, and where we can meet up together, showing that this is identical to this, the left and the right. So that's the three methods. We takes our choice, and basically usually on experience we find the easiest way through. One of those three it will be. Customarily, I think we start looking at this, intuitively speaking, I think we would start from the left and try and get as far as we can to the right and hopefully get there. So with that thought in mind, then let's go through this problem. So here the left hand side. Let's see what that equals then. Let's cross multiply these fractions. We're going to use fractions an awful lot when we do the manipulation in this section. So being good at manipulating fractions is a boon. So here cross multiply 2 sine theta minus, there's more than one term here, now we'll cross multiply, so put a bracket around it. 1 plus cot I'm going to write as cosine over sine. There's 1 plus cot, and move the sine up to be with it. Multiplied by the denominators multiplied together, sine squared. So here what have we got? We've got equal to then, we've got 2 sine theta minus, now I'm going to expand this bracket at the same time, sine with a minus. Then it's cosine over sine, the sines cancel to leave cos with a minus again, all over sine squared. Now we can tidy this up, 2 sine minus sine is 1 sine, minus the cosine over sine squared. Now we can split the fraction up. We're almost getting there, aren't we? So this will be sine over sine squared, which is 1 over sine, minus cosine over sine squared. Cos over sine is cot, so we can put one of the sines there, and then we've got 1 over sine again. So I should have written this as cosec here and here, shouldn't I, really, in this line? But let's do it now. So this is cosec minus cosec cot, isn't it? Because cosec is 1 over sine, and then we've got our cot. So this now equals then, take the cosec outside the bracket. So we've got there is common, 1 inside for this term, minus, then we need a cot here, don't we? And we've got the right hand side. So that illustrated the first of the three methods that we could choose. Start from the left and go to the right. We also need to be au fait with using fractions an awful lot. The only other thing I would like to mention perhaps is just the fact that we also in identities, it seems as though we use the difference between two squares an awful lot as well. So there's an identity that we need to have in our tool bag, so to speak, when we're looking at these problems and how to simplify them out. So okay then guys, all the best in this section. Hope you benefit from it and enjoy it, and I'll catch you in the next section. Cheers!